Hello guys, you are welcome to the GMAT 41's mathematics class. So in this channel, we are going to consider, in this class we are going to consider something quickly about the concept of limit of a function. Okay, we are supposed to have kicked off this class a moment before now, but I had class with our basic scholars, and then along the line, I encountered certain challenge, with network, and of course, I believe you senior students, those of you in higher level now, you are aware of the situation of network in, our country and environment. So bear with me, because this live class is going to be a quick one. Like I told you guys before now, when you start things early, you get the best and you do things on time. You will not spend the whole of, your precious time just wanting to cover up certain things, spending too much time on it. So today we are just going to look at the concept of limit, just something about it. And that will be all for the class. For further information to learn more, in the description box or section of this particular live class, I've already dropped the link to the video lessons on limit, where you can learn step by step the concept of limit, as well as different kind of questions that you might encounter when you are dealing with limits. So right away, I am going to introduce the definition of limit of a function, and then we pick, 1, 2 questions. So when you hear the limit of a function, what comes to your mind? In the simplest term, the limit of a function is simply the value that that function approaches as the independent variable approaches a given value. Does that make sense? I repeat that again. The limit of a function is the value to which that function approaches as the independent variable in that function approaches a certain value. If I give you a function, I can tell you evaluate that function at a given point. So that given point is not usually exact. We take it that, okay, the independent variable is approaching that given point. So once that happens, the function itself will be approaching a given value. Please, I'd like to check from the other end and know what is happening there, all right? Because like I said today, network is not friendly. So you are welcome to the class. Mercy, how are you? It's good to see you once again. All right, lag guy, I got exam coming. Engineering maths too tough. Nothing is tough in engineering maths. Please take note, guys. Become a channel member so that GMAT 41 will guide you very well, right? The things you are studying in school, they are 1 + 1. Yeah, the 1 + 1 is just all about you getting the foundation and secrets to it, and you won't have any challenge. Is that okay? Yeah, you won't. So become a channel member. Support this channel so you get access to critical video lessons. Yes, key video lessons that will solve any problem that you have. Like I said, for this concept of limits, in the description section of this video, so just at the end of this live class, make sure you click the description section, all right? And then you see where you used to have hashtag this, hashtag and that. Click on that, you see the link leading to this, the full lecture on limit of a function. I have defined the limit of a function already, and I told you it is the value to which that function approaches as the independent variable approaches a certain value. Remember, generally, if you are given, let y be equal to f of x. If y is equal to f of x, I can tell you or ask you to evaluate this function as the independent variable approaches a given value. The independent variable is x, independent. Then the dependent variable is y. So here, y depends on x. Like I said, for step-by-step detailed explanation of this whole concept of limits, please take the video lesson on limit of a function, full video lesson. And of course, to get access to that, you have to become a channel member, join the platinum level or diamond level, support this channel and get access to your full lectures, okay? And of course, that can also give you room to contact me directly for, one or two guides. But you have to become a channel member, very important. So you are giving y to be equal to a function of x. So y depends on x. That's just the meaning of this. I can ask you, find the limit of this function as this independent variable approaches a particular value. So this means that the limit of f of x, I am trying to bring out the concept of the definition of limit of a function. Limit of this function as the independent variable x approaches a given value. Let me say the value it is approaching is a. So the limit of this function as this independent variable approaches the value a should be equal to a given value, let's say k. Let's say k. These are generally numbers. A number, k number, right? So this is the definition of limit of a function. So by definition, let y equal to f of x. By definition, the limit of that function as the independent variable tends to a given value is equal to k. All right, having defined this concept of limit of a function, I want to tell you that it's important for you to know about the properties of 0 and infinity. The properties of 0 and what? Infinity. You need that a lot in the study of limit of a function. Okay, and we're not going to talk much about that in this particular live class because this live class is just 30 minutes or less. Yes, I've told you I'm not going to be spending a hell lot of time as we did, some time recently. I won't. So you want to learn fully from the channel, we have video lessons that covers this topic in full. Make use of them. In each of the live class, in the description box, you would always have the link to the full lecture on the topic. So we can all also rest. Now you should know about the properties of 0 and infinity. For example, if you multiply 0 by a number, you will get 0. Okay, you get 0. 0 times a number will give you 0. Yeah. Now, if you divide 0 by a number, you will get 0. If you divide 0 by a number, you get 0. For example, 0 divided by 2 is equal to 0. Like I said, if you multiply 0 by another number, you get 0. These properties are important for you to know. Now, what about this? If you divide, let's say, a number, say 1 now, 1 over 10. 1 over 10 will give you 0.1. We are aware of that, is that not so? How about I check for 1 over 100? 1 over 100 will give you 0.01. Can we go further? What about 1 over 1000? 1 over 1000 will give you 0.001. Okay, how about I increase this to 1 over 1 million? 1 over 1 million. If you work on this, it's going to be 0.0000001, 2, 3, 4, 5, 6, then 1. You know what happens here? The zeros will come first before the 1. And after the first 0, you put points. Then you now add up the number of zeros that will give you the total number of 0 there before 1 at the back or at the end. Now, if you look at the pattern of this number, the denominator is increasing in zeros, is increasing, and you observe that the numbers of zeros before the non-zero digits, which like here we have 1, which is non-zero. When you divide these by these numbers increasing 10, 100, 1000 in that order, the answer you are getting, you notice that the number of zeros, is increasing. before you would see a digit, a number that is not 0. This tells us something, that if I happen to increase this denominator to a number so large, very large, that you don't know what that number is, automatically this thing will approximate to 0, to become equal to 0. Think of this. If I have 1 divided, let me call that large number infinity. You know, your number line you have 0, 1, 2, 3. This thing increases to positive infinity. Then on the other side, minus 1, minus 2, it increases to negative infinity. So infinity is not a number, but we take it to be an assumption of a number that is so large that you don't even know it. You don't know it. And because you don't know this number, you cannot quote it to be a number. That is why anytime you hear of infinity, please, the concept of undefined. This is just an imagination of a number that sets a boundary for us as per the limits where we know the number up to. Let me assume that I know numbers 1, 2, 3, 4, 5, say up to 1 million, billion, trillion, quadrillion, zillion, whatever you want to call it. And then let us say that nonillion is the last number I know. Maybe somebody else knows more than nonillion, but maybe the last number I know is nonillion. Therefore, any other number above nonillion, because I don't know it, becomes an infinity to me. That is the whole idea of all this infinity. So you want to know the properties of zeros and infinity. Like in this case, 1 over infinity, or a number divided by infinity. I'm using 1 as the numerator just as a general case. It's not compulsory that the numerator must be 1. No. If I were to write the properties of zeros and infinity on the board, I wouldn't even use a number in the numerator there. I'll be using something like A or X, whatever the case is. Like I said, the full lecture on this topic contains the properties of zeros and infinity. You can take there. Become a channel member and get the best of GMAETS 41. 1 over 0 will now be approximately equal to 0. Yes. Because, if you have 0.000000, okay, let's continue. Where are we going to stop? The zeros we cut off. I don't think you are seeing this part of the board again. The zeros are still continuing. Because this number is so large, you don't know what it is. And this is approximately equal to what? 0. Properties of 0 and infinity. So if you divide any number by infinity, what are you going to get? You will get 0. Okay, you are expected to know the concept of indeterminate term. Anyway, before I talk about the indeterminate term, I hope you've gotten one idea about this. Like I've said, you want to learn more about these properties, take the full lecture on this. I was dividing, a number by a denominator where the denominator kept increasing. What if I reverse the process? Whereby I have 1 over 0.1. Let's reverse it. You are going to get 10 here. Okay, let us look at 1 over 0.01. You will get 100 here. Let's assume you have 1 over 0.001. This is going to give you 1,000. This is interesting. There is a pattern here. So what about I have 1 over 0.000001? 1, 2, 3, 4, 5 zeros. So this is going to give us 10,000. Am I correct? Or 100,000 rather. It's going to give us 100,000. Yeah. What do? Reverse the process now. This is 1 over 0.000 something. So if you want to get the answer, 1 will now come before you now have the zeros to follow up. So you notice that as you are dividing a particular number in the numerator by another number in the denominator, whereby the number in the denominator is decreasing, like it is approaching 0. That is what is happening in the denominator here. The denominators, they are moving towards 0. They are tending to 0. The answers you are getting larger. Eventually, if I happen to divide this thing by a number that is so small that I don't know what that number is. You can imagine. You know, negative numbers are less than 0, you know that. So if this moves to negative infinity serves as a boundary of the smallest number you can think of. So, you know, in this case, we are taking this to be, okay, let me divide this by infinity. So, just so small, you don't know. Right? I could fix that negative infinity or whatever if I want. But okay, let's say 0.000. Okay, the denominator will tend to 0 rather. Because like I say in the denominator, the values are approaching 0. Sorry that I'm trying to put infinity there. Okay, the values are approaching 0. Sorry. Okay, you can see that. They are tending to 0. So if I divide this thing now, eventually, that everything in the denominator becomes 0, then the final answer I will get here will be infinity. That infinity positive, you know, it means a number so large. Look at the answers we are getting: 10, 100, 1000. You know, it was increasing, 100,000. So if eventually the denominator becomes 0, the final result you are going to get will be a number so large that you don't know, and we call it infinity. That is that concept of undefined, which you refer to. Sometimes if you divide a numerator by 0, it will tell you that, okay, the guy is undefined. But like I said, for full understanding of this concept, I'm just showing you this. Please take the full lecture on concept of limits of a function. Take it so you can learn these properties very well. Okay, now what about I give you something like 0 divided by 0? This one you are saying is useless. It is meaningless. We call it indeterminate. You can't get it. What about infinity divided by infinity? It is indeterminate. It makes no sense. It's not even anything about undefined. Undefined is infinity. But if you have something like this, it does not make sense. That is what we are talking about. I would like you to go and find out, what if you add infinity to a number? Say infinity plus 2. What are you going to get? Find out. What about you divide infinity by a number? What will you get? Find out. I've told you these ones of indeterminate term, very significant, because most of you in your various schools, whenever you come to this indeterminate term, you see them usually in this format. Although there are other forms of indeterminate term, these ones usually are what we encounter whenever we meet problems in exam. All right, we want to pick questions and now solve on this concept. We're going to pick question and now solve. Please, I am sorry, I cannot actually follow up with what is happening on the other end from the camera, you know, because I can't be here and seeing what's happening in the camera. This device, I don't know what's happening. The network here has refused to cooperate, you know, the network on this device that I use to track what is happening at your end. Of course, I've just got to manage, you know, as it is. I've got to manage.